Hello, everybody. We're going to go ahead and start day 2 notes, and let's go ahead and get started. So today we are actually going to learn what there we go, clicking helps, compound inequalities are, okay? So let's go ahead and get started. We'll start off with the vocab. Compound inequalities are actually two inequalities joined together by either the word and or the word or. And what that does is it makes it so we have an even more restricted set of solutions. So instead of saying like, oh, it can be anything greater than 4, we might say it can be anything between, like, greater than 4, but still smaller than 10. Okay? Or we can do it the other way. We can say it can be anything less than 4, or it could be anything greater than 10. Alright? So here are some examples of the kind of problems that you'll see. You'll notice that it's not solved for the x already. So you'll still have to solve for x the way it is. So it's basically doing the same one or two step or maybe multi-step equation or inequality, but you're doing it twice as many. Okay? So solving compound inequalities is just like solving a single inequality, just like I said. You need to solve each inequality separately and then use the same word, whether it was the and or the or that they gave you. Okay? And, oh, gosh, you do not... Hold up. Did I even give you room to write this down? Oh, okay, I gave you spaces. Sorry. I have to remember what your notes look like, so... So, if there is no word in the compound inequality, like the last example, we can start solving in the middle and do the inverse operations to both the left and right side of the inequality. So that seems very wordy and very confusing, and I know, because I'm even confused and I know what I'm talking about. Which is sad. I wrote the thing. So I'll show you an example of this, because sometimes they don't use the word because it's obsolete almost, so you don't have to use the word, but it still has its same meaning. So I'll show you multiple ways you can do this, okay? And if you're still confused when we get to class, please let me know. We can go over it more in class, and that's what I want to do. Okay, so we're going to solve this compound inequality. We're also going to graph it on a number line and write it in set builder notation. So this one says v is less than 6. No, it's not. V minus 6 is less than or equal to negative 9, or 7v is less than... Why? Guys, I cannot talk. I'm recording this very late at night. I'm trying to get ahead of this stuff, and it's not a good idea for me. Little Miss Scully. Okay, it says v minus 6 is greater than or equal to negative 9, or 7v is less than negative 28. Okay, so it's the word or. Okay, that's really important that we know that, because that's also going to be in our answer. Okay, now you can see there's two very distinct inequalities. We're just going to go ahead and solve them like we normally would. So v minus 6 is greater than or equal to negative 9. We're just trying to get v by itself. So we go ahead and add 6 to both sides. We get v is greater than or equal to negative 3. Same thing over here. 7v is less than negative 28. Go ahead and solve for v. We just divide everything by 7. So we end up getting v is less than negative 4. And then that or we bring down. Okay? So what we're saying here is that v can be anything greater than or equal to negative 3, or it could be anything less than negative 4. Those numbers that satisfy either of these inequalities, like I can plug into either v and it would make a true statement for either one, those are our solutions. Okay? So let's go ahead and graph it, because I feel like the graph gives you a really good understanding of what this means. Okay? So we go ahead and graph the first one. V is less than or equal to negative 3. So we put a closed circle on negative 3. Sorry, why do I keep saying less than? V is greater than or equal to negative 3. Put a closed circle on negative 3 and point to everything greater than negative 3. Then the V is less than negative 4, we go ahead and graph that as well. Here's negative 4, and less than means we're pointing to everything smaller than it, and it's an open circle because it's not equal to, okay? Or statements will always have two graphs, okay? So, they will always have two separate graphs, alright? Because it can either, like, negative 10, for example, is a solution because it works for the v is less than negative 4. It does not work for the v is greater than or equal to negative 3, but that's okay because that's what or means. It could be either of these. As long as it satisfies one, it's a solution. Alright? So here is an example of the other kind. Again, I'm just checking your notes to make sure it's the same thing, because I get a little confused sometimes. Yep, yeah, we're good. Okay, there's your try on your own. Put them at the end. That's why I'm a little confused. So this one, solve the compound inequality graph and write the interval notation. Ooh, we're not going to do interval notation. I just realized I did not do step builder notation for you. So we did all this stuff. We got the or. We graphed it. There we go. There we go. And then step builder notation. Ooh, oh my gosh, doing the jumpy thing again. So step builder notation, we just write it with the or statement in there. Okay? Nothing fancy. Now, honors, I'm going to have to show you interval notation, because interval notation is a lot easier, and I like showing it to people. But here's a little preview of what it looks like. It's basically taking the smallest number and the largest number of that section and putting it in parentheses. So I'll show you interval notation later on. Okay? It's not on your SOL, so it's not a top priority for me. So we're not going to write in interval notation. We're only going to write in step builder, so that means I'm going to have to do it by hand, which is fine. So we have to solve this. Now this essentially is the compound. This is what compound means. It's put together. So this is two inequalities just merged together, right? Well, it's okay because when it's merged together, that actually tells us specifically what kind of compound inequality it is. And that's an and compound inequality. So you can do this multiple ways. The easiest for you to understand right now is just to take the first part. Ooh, see? So you want to take the negative 1 is less than a over 9. And you want to just go ahead and separate that out. If you make them into two different inequalities, you can go ahead and do that and just put the word and in between. And what that means then is that you are going to go ahead and rewrite that middle term for both inequalities. Okay? So that means you just go ahead and multiply everything, both sides by 9, do it on the other one as well, and it's going to give you your solutions. Okay? Oh, clickety click, click, clickety click, click. Why is it not clicking? Guys, why does technology not like me? At all. It really does not like me. Gosh, it's too big to move. I'm sorry, guys. Go away. Okay, so then I end up getting negative 9 is less than a, and a is less than 0. Okay? So those are my two inequalities. Now the word and means it has to satisfy both. So it has to be, this actually means it has to be greater than negative 9. So it has to be bigger than negative 9 and smaller than 0. So that gives us a very small window of where our solutions are. So we're going to go ahead and graph it. Okay? Oh, look, I did write step builder notation. Where's all this stuff happening down here? Oh. I think something like that. I don't know what those are. So, here, I already opened up the graph. Basically, I'm going to do the circle for the -9, the open circle for the -9, and a closed circle for 0. Now, because I'm less than 0, the line's going to go to the left, but I'm greater than -9, it's going to the right. So basically what I'm doing is I'm connecting those two dots, because only the stuff in between those two dots are going to be solutions to this inequality. Okay? So with and statements, you are connecting them together. And for some reason it doesn't, I don't have that written anywhere. That'd be good. And statements create one line. That looks good as soon as I make it small enough. And statements create one line. Okay? Set builder notation. Oh, I know what I did. So because they both have the A here, I can go ahead and combine them just like this to create one inequality if I wanted to make it truly compound. Or I can go ahead and write it with the word and. Those are both acceptable, and that's how you can write it in set builder notation. Okay? So however you want to write it is totally up to you. Ooh, that's not what I wanted to move. That's still not what I want to move. This one. Okay? So you can see the two different inequalities here. Okay? And that's it. That's compound inequalities. It's just like solving one step, or not one step, it's just like solving normal inequalities. It's just you have that added understanding of what or and means. Okay? So, the next two problems are the try on your owns. So you're going to go ahead and give these. Honors, don't worry about writing them in interval notation. I don't know why I wrote that. I forgot to delete it. So, just go ahead and worry about set builder. There are two try on your owns. Oh, goodness. And you're going to go ahead and give that a whirl. Okay? If you have any questions, write them down, because this, I feel like this is one of the lessons that I don't like putting on a video, because it is one of those ones where it's a little bit more in depth. So we'll probably spend a good amount of class time going over this, making sure you guys fully understand it before the activity. Okay? Sorry I got a little chatty with it. Again, it's one of the ones I want to make sure you guys get a full understanding with. But I will see you next class. Okay? Bye.